Right around your 30th birthday, an invisible clock starts ticking. Deep inside your body, your cells begin to lose their ability to repair themselves. It is a slow, quiet structural decay that steadily erodes the tissues making up your muscles and your brain. If we look at this chart mapping human muscle mass over a lifespan, the trend is undeniable. Starting at age 30, you lose 3 to 8% of your total muscle mass every decade. As you cross age 60, that downward line gets steeper. That cellular loss eventually catches up with you in the physical world. The muscles stabilizing your joints become smaller and weaker. Suddenly, stepping off a curb requires immense effort, and you begin losing the ability to move through life on your own terms. Many of us assume we're fighting this process just by going for a casual neighborhood walk. But a leisurely stroll simply doesn't challenge your body enough to trigger the biological mechanisms required to halt that structural decay. If you do nothing, a wheelchair or a complete loss of autonomy becomes the default biological destination. But this physical deterioration is not a permanent one-way street. By applying the exact right biological stresses to your body, you can actually force your tissues to rebuild. As we get older, we also tend to accept brain fog, memory slips, and a general slowing of our cognitive function as normal, unavoidable parts of life. But those symptoms are the result of physical shrinkage inside your head. Two specific structures, the prefrontal cortex, which handles your focus, and the hippocampus, where you form long-term memories, are highly susceptible to tissue loss over time. To stop that shrinkage, your brain requires aerobic exercise. Whether it is a water aerobics class, cycling, or a brisk power walk, the goal is to consistently push your heart and lungs to work significantly harder than usual. When you elevate your cardiovascular output, your body immediately floods with neurotransmitters like dopamine. More importantly, that exertion triggers neurogenesis. Your brain manufactures brand new cells right inside the hippocampus. As those new cells multiply and wire together, the physical volume of the hippocampus expands. You are building thicker, denser brain tissue, making it much harder for neurodegenerative conditions like Alzheimer's disease to break those structures down. Pushing your heart rate provides more than a boost to your stamina. It physically reinforces the structures that house your memory and your identity. A snagged slipper or a wrinkled rug might seem like a minor annoyance, but for an older adult, it can instantly become a life-threatening emergency. Falls are the leading cause of fatal injuries in later life. The reason these simple trips turn into devastating falls happens deep inside the neuromuscular system. As nerves age, they lose their protective myelin coating, which slows down the electrical signals traveling between your limbs and your brain. You lose proprioception, the unconscious awareness of where your body is in space. With these warning signals delayed, the older body lacks the microseconds needed to shift weight. Instead, it locks up and stiffens the ankles, guaranteeing a loss of balance. To repair this broken communication loop, you have to practice movements that force your brain to coordinate with your stabilizing muscles. Practices like Tai Chi deliberately put you in unstable positions, forcing those neural pathways to fire and adapt. You are repairing the wiring of your nervous system. By keeping that brain-to-muscle connection sharp, you restore your body's ability to catch itself before a slip becomes a hospital visit. Even without a fall, everyday tasks can quietly become overwhelming. Hauling a bag of groceries to the car or lifting a suitcase can suddenly feel like an impossible physical burden. Doctors call this physiological vulnerability frailty. It is largely driven by sarcopenia. Inside your muscles, the fast-twitch type 2 fibers, the ones responsible for explosive power and heavy lifting, systematically shrink and die off. The only way to stop this decay is to give your muscles a reason to survive. You have to strain your tissues using free weights, resistance machines, or your own body weight. When you push a muscle to its absolute limit, the surviving motor neurons realize they need help. They reach out and recruit dormant, neighboring muscle fibers to help carry the new load. Those active fibers then grow thicker and stronger to handle the stress. But you cannot build that new tissue out of thin air. To fuel this physical reconstruction, your body requires raw materials, specifically around 1.3 grams of protein per kilogram of body weight every single day. Combining that protein intake with resistance training is the literal reconstruction of your physical hardware. It gives you the power to walk up a flight of stairs completely unassisted. Strenuous movement triggers anatomical changes that no pharmaceutical or dietary intervention can replicate. It serves as the specific biological signal that instructs your body to restructure its own tissues. To outlive the biological aging process, you need a routine that hits 4 distinct targets. You must build strength through resistance, expand your aerobic capacity through cardio, sharpen neurological coordination with balance drills, and maintain joint range of motion through flexibility exercises. The clinical dosage required to trigger these cellular changes is highly specific. You need to hit those targets for a minimum of 30 minutes, 3 to 4 times a week. If you have been sedentary, jumping straight into heavy weights or intense running often overloads unconditioned connective tissue, leading to inflammation and tears. The most effective strategy is to start low and go incredibly slow, allowing your joints and tissues the time they need to adapt to the new demands. Chronological time will advance no matter what we do, but by forcing ourselves to adapt, grow, and rebuild, we possess the biological tools to dictate our autonomy and our quality of life in our final decades.